Hello students, and welcome to another edition of Mr. Hargrove's math class, where today we're going to talk about writing and solving equations and inequalities from word problems. The previous lesson that you saw, we talked about writing two-step inequalities, and today we're going to write two-step inequalities and equations, but we're going to learn how to do it from word problems. So please make sure that you have pencil, paper, as well as a calculator with you for this lesson. We're going to go ahead and jump into the learning target. Today's learning target reads as such: students will learn how to write and solve equations and inequalities from word problems. And the success criteria is listed here. We need to be able to do a few things to reach our learning target, and they're listed here. We need to be able to read the word problem. We need to be able to determine what the variable or the unknown represents. That's going to be a very critical part of today's lesson. We also need to be able to identify the number that goes with the variable. Now that is the specific math term for that is the coefficient. We need to be able to identify what the coefficient is. And the coefficient is going to be like the best friend of the variable. They go together. We need to be able to identify the number that represents the total, the maximum, or the minimum amount. We need to be able to identify the number that represents the constant. We need to be able to identify the vocabulary to determine which inequality sign to use. And then we need to be able to write equations and inequalities, solve equations and inequalities, and then plug our solution back into the original problem to check for accuracy. So, a lot to do, but you're going to see as we do it. It's pretty straightforward. The prerequisite knowledge: this is what you need to know beforehand in order to be successful with today's lesson. Students should understand the rules associated with adding, subtracting, multiplying, and dividing rational numbers, especially the integers. Students should know how to solve two-step equations and inequalities, which we spoke about that in our previous lesson. And students should know how to plug in their solution to check for reasonableness, which is another thing that we learned in the previous lesson. So let's go ahead and jump into this. Let's look at some equation word problems. So if we look at this first problem, Sammy wants to buy some CDs that cost $14 each and a DVD that costs $23. She has $65. Write and solve an equation to determine how many CDs she can buy. Now, when I get to this problem, the first thing I want to do is identify what does our variable represent? What is the piece that we are trying to figure out? And it's right here in that last sentence. We're trying to figure out how many CDs Sammy can buy. So we're going to say that that's X. That's the unknown piece that we're trying to figure out. Now, after I figure that out, I need to ask myself, well, what is the coefficient? So what is the number in the problem that is linked very closely to X? And X represents how many CDs she can buy. So did they give us any information about CDs, any other information? And they did. They told us that each CD is $14. And that is a very important piece of information. So this equation will start this way: $14 per an unknown amount of CDs. And what else does Sammy want to buy? Well, she also wants to buy a DVD that costs $23, and she has a total of $65. So that is the equation. Now we want to solve it. Remember, the first step to solving it is to put a box around the variable and the coefficient, and then we want to subtract. Because it says plus 23, we want to do the opposite of that. So we're going to subtract 23 to 0, period. And then we're just going to bring down what's left, which is 14x equals 65 minus 23 is 42. And now I'm going to divide both sides by the number that I put a box around, which is 14. The coefficient, the number next to x, that's what you divide both sides by. And when you do 42 divided by 14, we get x equals 3. So that means that Sammy can buy 3 CDs, because that's what the problem says. Wants us to figure out how many CDs she can buy. She can buy 3 CDs. Now, it's always important to check to make sure that your solution is correct. So what I'm going to do is I'm going to go back and I'm going to write this original equation, but instead of x, I'm going to plug in my solution, which is 3. And I'm going to see if when I add 23 to that, does it give me 65 as the equation says it should. 14 times 3 is 42. And 42 plus 23 is 65. So 65 equals 65. So therefore, my solution of x equals 3 is correct. Anytime throughout this video, feel free to pause, replay as needed. But this is how we do these problems. So it's not that bad. I'm gonna erase this one and we're gonna transition to another problem where we will practice the same skill. And this is equation example 2, where it says Layla bought a magazine for $5 and 4 12-ounce bottles of Pepsi. She spent a total of $15. Write and solve an equation to find out how much she paid for each Pepsi. So my unknown piece that I'm trying to figure out here is how much she paid for each Pepsi. That's X. And you can use any letter, any variable, but for today we're just going to use X. Keep it simple. Now, what other information did they give us that's closely related to how much she paid for each Pepsi? Well, this problem, they're trying to trick you a little bit because they threw in this bit of information, 12 ounces. But it's not important for me to know how much the Pepsis weigh because that has nothing to do with figuring out how much she paid for each Pepsi. So I can put an X through that. That's just an extra number that's there to throw me off. But I do know that she bought 4 bottles of Pepsi. So that's important. So this equation is going to start 4x. And what else did Layla buy? Well, she also bought a magazine for $5. So we're going to add that to the cost. And it says that she spent a total of $15. So that's the equation. And now I want to solve it. I'm going to put a box around my variable and the coefficient. And then I'm going to get rid of what I did not put a box around. We get rid of plus 5 by doing minus 5 on both sides. And then we're going to bring down what's left, which is 4x equals 15 minus 5 is 10. I then need to divide both sides by 4. And when I do, that's going to give me x equals 10 divided by 4, which is 2.5. So another way we can put this is that she paid $2.50 per Pepsi. Each Pepsi, $2.50, which is the same thing as 2.5. And then always double check. Write the original equation, but this time instead of x, write 2.5 plus 5 and see, do you get 15? 4 times 2.5, 4 times 2.5 is 10. And then 10 plus 5 is 15. 15 equals 15. So that is again how I know I solved it correctly. See, we're doing the same thing each time. It's all about knowing what to look for, underlining key things in the problem, and that's going to help you each time. So now let's look at example 3. It says James won 40 unique pencils at his school's game night. Later he gave 2 to each of his friends. He only has 8 remaining. Write and solve an equation to find out how many friends he has. Okay, so he won 40 unique pencils. We're trying to figure out how many friends he has. That is what my unknown represents. Now, did they give me any information that is closely related to how many friends he has? And they did. They told me that with those unique pencils, he gave 2 to each of his friends. So that's very important information. Now this problem is going to look a little different because he started out with 40 pencils and then he's giving them away. So we're going to subtract, and he's giving away 2 per each friend, and we don't know how many friends he has. So we're saying 40 minus 2x equals, how many does he have left? He has 8 remaining. So this is what this equation is going to look like. And if you're more comfortable, you can flip this around so that it looks like this. Minus 2x is the same thing as negative 2x. This is a positive 40, so we're going to keep it positive. So you can flip it around to solve it that way. You don't have to, but it's an option. And I'm going to subtract 40. And this is why I said you got to be real strong on your integer skills here. That's going to leave us with negative 2x equals, what is 8 minus 40? Well, I have more negatives here, so I know my answer will be negative. And then I just do 40 minus 8, which gives me 32. So my answer is negative 32 over here. Divide both sides by negative 2. Remember, you're always going to divide both sides by whatever number is next to x. Unless you have a fraction, then we'll do something a little different, but we'll get there. That's going to give us x equals, a negative divided by a negative is a positive. 32 divided by 2 is 16. So we would say 16 friends. 16 friends. And now, if I want to double check it, I can go and plug this number into either form, but let's go with the form that I used to solve it. So negative, instead of x, let me replace that. Instead of x, I'm going to plug in 16, add 40, and see, does that give me 8? Negative 2 times 16 is negative 32. And negative 32 plus 40 does give me 8. So I can say 8 equals 8. So I have solved this one correctly. All right, we're moving right along. We're going to look at one more equation before we jump into the inequalities. And it's here. It says, Jill sold half of her comic books and then brought 16 more. She now has 36. Write and solve an equation to find out how many comic books she began with. Okay, so we're going to go ahead and look at this one. And what we're trying to figure out here, how many comic books did she begin with? So that is what X represents. How many comic books did she start with? And what other information did they give me that's related to how many comic books she started with? And it's right here. It says she sold half her comic books. So you got to think, well, what's a way to represent half? Well, we can use the fraction, well, half of the number of comic books she began with. And then it says that she bought 16 more. So we're going to add 16 and set that equal to how many she has now, which is 36. So this equation has a fraction, but you can also make that half a decimal. You can make it 0.5x and it'll come to the same thing. Now we need to solve it. Let's put a box around our variable and the coefficient. We need to subtract 16 on both sides. And that's going to give us 1/2 x equals 36 minus 16, that gives us 20. And now remember, when you have a fraction, you want to make the fraction go away. How do you make the fraction go away? Well, if I multiply both sides by the denominator, that makes the fraction go away. And that's just supposed to be a 2. And we'll go ahead and put this over 1 since it's a fraction. That's how we multiply fractions. 2 times 1 is 2, 1 times 2 is 2. So 2 over 2, that's just going to leave me with x. So this is going to be x equals whatever 20 times 2 is, which is 40. So we can say that Jill started with 40 comic books. And now we can check to make sure that that is correct. So let's do 1/2. And instead of x, we're going to plug in 40, but remember, we're going to do 40 over 1. Anytime you multiply fractions, that's what you want to do. We're going to add 16 and see, does that give us 36? Well, 1/2 times 40 over 1 is going to give me 40, because 1 times 40 is 40, 2 times 1 is 2. 40 divided by 2 is 20. And then 20 plus 16 is 36. So 36 equals 36. So that's how we know we did this one correctly. Always check your solution when you solve an equation and an inequality. So we'll go ahead and we'll jump now to our next section, which is going to be looking at some inequality word problems. So let's go ahead and look at some inequality word problems. And before we do that, it's very important that we look at some vocabulary. With inequalities, you're going to be using the inequality sign. So you have the less than sign, the less than or equal to, the greater than, and the greater than or equal to. And what you see listed here are some key vocabulary words that let you know what symbol to use. See, whenever I'm dealing with less than, my vocabulary words will be here. These are typical vocabulary words that I'll see below: fewer than, under, less than. When I'm dealing with less than or equal to, that's when you'll see terms like at most, does not exceed, no more than, not above, up to, maximum, greatest number. That's less than or equal to. Greater than, right here, greater than, you see phrases or words like above, exceeds, more than, over. And then when it's greater than or equal to, key phrases that you may see: at least, no fewer than, no less than, not under, minimum, smallest number. These are just typical phrases and words that you'll see, and they'll help you figure out which inequality sign that you should use. So it's going to be a good practice to have this list close to you when you're solving inequality problems. And it's kind of like training wheels. You use it until you don't need it anymore. Once you practice this long enough, you'll find you won't need this anymore. The symbol will come to mind when you hear the phrase. So let's look at this first example. It says Sarah needs to buy 3 identical shirts to wear to work. She has a $15 gift certificate. Including using the gift certificate, she can spend no more than $60. Write and solve and graph an inequality that could be used to determine the possible cost for a shirt. So what does X represent here? Well, X represents the Possible cost for a shirt. That's the unknown piece that I'm trying to figure out. And while we're here, we need to look at some vocabulary, because we know that this is an inequality because it gave us a certain phrase. Okay? It says that she can spend no more than $60. So that's what lets me know that this is an inequality. Now the question is, which inequality symbol am I going to use? Well, it's the less than or equal to that gives us this phrase, no more than. And we see that phrase up here. So I already know that I'm going to use this less than or equal to inequality symbol. But now I've got to fill in the other parts. The possible cost for a shirt. Is there any other information about cost for a shirt in the word problem? Any info that's related to that? And it is. They told us that she bought 3 identical shirts. So this inequality, is going to start 3x. So it also says that she has a $15 gift certificate. Now, how does a gift certificate work? Does a gift certificate add to the cost, or does it take away? And absolutely, if you have a gift certificate, that's money that's going to be subtracted from the cost. So this is 3x minus 15. I already know my inequality symbol will be less than or equal to. And it says that she can spend no more than 60. So that's the inequality right there. Now I'm just going to solve it. Remember, we solve it the same way we solve equations. And then we're going to bring down what is left, which is, so if this is minus 15, I'm going to do the opposite. I'm going to add 15. Always do the opposite. Now we bring down what's left. 60 plus 15. It's going to give us 75. And then I'm going to divide both sides by 3. My sign will remain in the same direction. And 75 divided by 3, $25. So this is saying the possible cost for a shirt is $25. It's saying that the shirt needs to be less than or equal to $25. Less than or equal to $25. Now this problem does tell us to graph. So what does that look like? If the cost needs to be less than or equal to $25, let's say this is 24, 25, and 26. What we're going to be looking at here is a closed dot on the $25 because the cost can be less than or equal to, and the prices are going to go this direction because they can't be more than 25, but they can be less than. So that shirt could cost $10, it can cost $13, it can cost $14, it can cost $24, but the shirts cannot cost $26. It could even cost $25 or less. Okay. And when you're plugging in your answer to check for inequalities, here's something you can do. You can just test it out. So let's think of a number that is less than 25. So let's look at a number like 20. And this is how I'm going to test my inequality. Think of a number less than 25. And that's a number that actually fits in the solution set. So 3 times 20, that's going to give me 60. And then 60 minus 15 is going to give me 45. Now, is 45 less than or equal to 60? And indeed it is. It's less than. So that's proof that when I plug in a number that is less than 25, the inequality is true. But now, let's plug in a number that is more, greater than 25. And let's go with a number like 30. So 3 times 30, it gives me 90. 90 minus 15. 90 minus 15. So when we think about this, and again, it's very important that you just consider all aspects of this problem. All aspects of this problem, okay? 90 minus 15. That's going to give me 75. Now, is 75 less than or equal to 60? It is not. And that's what I mean when I say consider all aspects of the problem. 75 is not less than or equal to 60, so this inequality is not true. And why is it not true? Well, because I plugged in a number that is greater than 25, and the inequality is saying that it will only work with numbers that are less than or equal to 25. So that means if Sarah wants to buy a $30 shirt, she will not be able to do that if she plans to spend no more than $60. The shirt can't be 30. The shirt has to be 25 or less. So inequalities, they have a little more going on, but it's one of those concepts, if you practice it well, you'll be just fine. But it does take a little more attention to detail when you're solving inequalities. So let's look at the next example. It says, Daniel has $25 to spend at the fair. If admission to the fair is $4 and the rides cost $1.50 each, what is the greatest number of rides that Daniel can go on? Well, if I look at this problem, the greatest number of rides that Daniel can go on, that is what X represents. The greatest number of rides Daniel can go on. That's the unknown piece. That's what I'm trying to figure out. I'm trying to figure out the greatest number of rides that he can go on. Now I know that this is an inequality because of that word greatest, or that phrase, greatest number. Greatest number. And if I look here, the greatest number is right there. So that's how I know that I'm going to use the less than or equal to inequality sign. So what piece of information in this problem is closely related to rides that Daniel can go on? Well, they told us the cost of each ride. They told us that each ride is $1.50. So this one's going to be $1.50 X. What other items is Daniel paying for? Well, he has to pay $4 just to get in. And then it says that the greatest number that Daniel can spend, he says he has $25, so that's the greatest amount that he has to spend. He can't spend any more than $25. And now we can go ahead and solve this one. Plus 4, we're going to do the opposite. We're going to do minus 4. And that's going to give us $1.50x is less than or equal to 21. Divide both sides by 1.5. And that's going to give us 21 divided by 1.5, 14. So the greatest number of rides that Daniel can go on is 14 rides. Now I can graph that. Let's say that this is 13, 14, 15. This is another situation where we're going to have a closed dot, arrow pointing this direction, because Daniel can ride 13 rides. He can ride 14. He can ride any number this direction, okay? 12, 11, 10, 9, but he cannot ride 15. If he rides 15, he he is going to spend more than $25 and says he only has 25. So again, we can do the same thing that we did with the previous problem and just plug some numbers in and see what happens. So let's start with $1.50. Let's think of a number that is less than 14. So let's go with a number like 10. He can ride 10 rides, and this inequality, once we solve it, will prove that. $1.5 times 10, that's going to give me 15. And then 15 plus 4 is 19. 19 is less than 25. So 19 is less than or equal to 25, so this inequality is still true. Now, what is going to happen, do you think, when we plug in a number that's greater than 14? You guessed it right. The inequality will no longer be true. So let's think of a number that's greater than 14, and let's go with 20. See what we get. Let's plug in a 20. So 1.5 times 20, that gives us 30. And then 30 plus 4, that gives us 34. Is 34 less than or equal to 25? It's not. So that's proof that when I plug in a number that is greater than 14, it shows that Daniel can no longer use the $25 the way he wants to. He needs more money to ride 20 rides. Very good. Okay, so we'll look at one more example of an inequality word problem. We'll practice this same steps that we went through. It says the 7th grade class is putting on a variety show to raise money. It costs $800 to rent the banquet hall that they are going to use. If they charge $15 for each ticket, how many tickets do they need to sell in order to raise more than $1,000? So X, how many tickets do they need to sell in order to raise more than $1,000? That is my unknown. That is what X represents. How many tickets do they need to sell? Now I know that this is an inequality because of this phrase in the problem. It tells us that the 7th grade class putting on a variety show and costs $800, and it says that they need to raise more than $1,000. That means that I'm going to use the greater than inequality symbol. So let's go ahead and write this. How many tickets do they need to sell? What information did they give us that's related to tickets? They told us that they plan to charge $15 for each ticket. So this inequality will start like this, 15x. Now, this is one where you got to pay attention to the words. They're going to make money from selling tickets, but they also have to spend some money because it says it costs $800 to rent the banquet hall. So that $800 is money that's going to be taken out because it's money that they have to spend. And it says that the goal is for them to make more than 1,000, so more than $1,000. That's how we write this one, and now we're going to solve it. Same exact way we've been solving it. Box around variable and coefficient. This says minus 800, so we're going to do the opposite. We're going to add 800 to both sides. And when I do, I'm going to bring down what's left, which is 15x is greater than 1,800. And now I need to divide both sides by 15. And when I do, I get x needs to be greater than 120. So this means they need to sell more than 120 tickets. If I graph this, this is what it looks like. Let's say this is 119 tickets, this is 120 tickets, this is 121 tickets. If X needs to be greater than 120, then X cannot be 120, which means I'm going to have an open dot. The open dot means that it can't be that number, but arrow's going to point this direction because it needs to be more than 120. So we can sell 121 tickets and be okay. But if we only sell 119 or 113, then we are not going to make more than $1,000. Okay? We're not going to make more than $1,000. So I want you to plug in some different numbers into this inequality and prove it. And what you're going to find is that when you plug in, you rewrite this inequality. If you plug in a number that is less than 120, you will not be able to afford it. And we'll see. Let's go with it. Let's choose a number like 110 tickets. 110 tickets. And we'll say 110 minus that 800 needs to be greater than 1,000. So 15 times 110, that's going to give me 1,650. And then 1,650 minus 800, that's going to give me 850. Now 850 is not greater than $1,000. So we see when we sell a number of tickets that is less than 120, we only end up making $850, which is not greater than 1,000. So that doesn't work. And then you can do the opposite. Is true as well. If you choose a number that is greater than 120, and I want you to practice that on your own, you will see that you're going to have a number here that's greater than $1,000. Only if you choose a number that's greater than 120. So practice that. Okay, so that is it for writing and solving inequalities with word problems. From word problems, I want to thank you for your attention and let you know that I greatly appreciate it, and I'm looking forward to meeting you back here again for the next edition of Mr. Hargrove's math class.